All right, guys, we're back. And a big thanks again to Jens for falling in tonight. He has just returned from dentist, so if he slisses or whatever a bit, then don't blame him. Good luck.
Thanks, Nick. All right. I'm Jens. I order a shit ton of stuff online. Recently, I ordered this super cool stainless steel fermenter to start brewing my own beer. But that's a completely different story. The annoying thing is, though, when the mailman tries to deliver all my packages, I'm not home. And I have to go to the postal office to get my package. I go there. The first thing he asks is my ID card. He verifies that my name that's on my ID card is the one to which the package is addressed. He checks if my ID card is not expired yet. He matches the image on my ID card with my face. He basically checks if it's not a fake ID card, that I'm not just claiming any package that is there. Probably because the ID card is quite difficult to fake. It's like a plastic card. It has a chip in it. It has a watermark on it. So it's quite difficult to fake or to tamper with in some way. But that got me thinking, like, how do we authenticate ourselves in the digital world, and why is it so different? Like, usually we just have a form on a website where we put in our username and password that gets sent to the backend, to the server. That server does a lookup in the database because it wants to check if my password matches. It also usually initializes a session in a session storage like Redis or a database or something. And eventually it returns like a response with a cookie attached to it with your session ID. Right? Everyone still with me? Right. And then on every other request that you do to the server, you pass along this session cookie with your ID in it, and the server has to do another query to your session storage and or database to fetch your user information. I mean, imagine doing this in the real world with the postal office. The guy there at the counter, like, we get an ID from like a literal string of just numbers or integers from the government on a piece of paper. We go with our piece of paper to the guy behind the counter, and we say, okay, I'm apparently this guy attached to this number, and he has to call the Belgian government every single time a customer approaches him. I mean, I can imagine that's not really that fun, and he will turn into this guy, like an angry guy, just overloaded with too much work. And this also kind of feels, or this kind of indicates a problem why the typical way of authentication is not really that fitting for like a microservice or a distributed architecture. I mean, if every postal office has to just call or query the government, then that puts a lot of load on the government. This is similar to like a microservice architecture where every microservice should have access to your session storage or your user database. It's maybe not the best setup we should go for. That got me thinking, like, what would a digital ID card look like? And maybe we should try to build it so that we can apply what we have from the real world also in a digital world. So let's go for a short checklist. First, the data needs to be readable by any application. I guess this is quite an easy one on our checklist. I mean, if you get it, you need to be able to read it. If you get the Belgian ID card, actually not sure if the text on your Belgian ID card is English or Dutch. Not Dutch sure, actually. It should have a limited lifespan, like your real-world ID card also has like an expiry date. We should make sure that our digital version has that built in. We also need to protect ourselves from fake ID cards, so built in a mechanism that if users or people try to impersonate someone else, that we can detect that. And we can protect ourselves from data tampering, just changing your name or whatever, that's not happening without you knowing that that's going on. So first thing, it needs to be readable by many applications. So let's go for a language or like a format that is usable by, I think, every programming language out there, XML. But then again, you guys are, I think, front-end developers, so maybe let's switch to JSON, because why not? In there, so if we build our digital ID card in just a simple JSON object, we first need to at least have some information about the issuer. In this case, the Belgian government. The main reason why issuer is abbreviated here is just so that we reduce the amount of data on our ID cards, because we need to send it along with requests in the end. Then we need some information about the subject, who I am. So let's also build a key in there called subject with a reference to our national identification number. Then we need that information that is really specific to the expiration or the issuing date of our ID card. So also let's have an issued at timestamp and an expiry timestamp in there as well, so that we can check, is this ID card expired or not? And then we can also put in whatever additional information we want about the user, your name, your gender, or whatever. But because we are going to send this ID card or this digital ID card on the wire or with HTTP requests, maybe JSON isn't really the best way to do it. So let's make sure we make it URL safe at least. So let's base64 encode that data so that we can add it as a header or add it as a parameter in our URLs. Makes sense? So let's run through our checklist again. Okay, is it easily readable by applications? Yep, it's JSON, but base64 encoded to make it URL safe. Do we have a protection against like the lifespan? Can we check if the ID card is expired? Yeah, we can. We have the both. We have the issued at and the expires timestamp built into that data. But are we protected against fake ID cards? Nope. Are we protected against data tampering? Still not. It's just JSON. We can change whatever we want, base64 encoded, but it's still not protected. So we need to figure out a way to have like a signature printed on our ID card by the government saying, this is what I issued, this is what is in here. This signature needs to prove the authenticity so that it's issued by the government, and also the integrity that whatever was on there hasn't been changed since the government issued it to you. How do we do this? Blockchain? Maybe, but not yet. But let's use something on which blockchain is heavily based. Asymmetric cryptography, also quite known as public key cryptography. It's already quite often used to create digital signatures, and it's already used by many protocols out there like SSH, HTTPS. So why not use something really battle tested for our digital ID card as well? A short recap of asymmetric cryptography. You basically have a pair of keys, a public key, a private key. Your public key is meant to be shared with whoever you want to communicate with, and your private key is meant to be kept very secret. You can use either keys to encrypt data, but the opposite key is used to decrypt that data again. If you encrypt it with a private key and try to decrypt it with a public key that was not linked or that is not the opposite key of that original private key, then you will get just back gibberish. It doesn't work. You need to have the both sets of keys to be able to decrypt and encrypt it. So how do we use this for our digital ID card? So we take our base64 encoded data and we hash it with, for example, a SHA-512 because we want to reduce the amount of data that is eventually going to be in our signature. The larger the data is going to become in our token, in our digital ID cards, we want to have our signature being independent from that size. The data can grow, but eventually the signature should remain the same size. So that's what this hashing step is for. So we reduce the amount of data, and then with our private key, we encrypt this. Right? So I think it's quite clear to say that whenever something changes on the left side in our data, that we will end up with an entirely different signature. Just the hashing function alone, just changing one bit, will result in a completely different hash, and then again, a complete unique digital signature at the end. So this is it. This is our digital signature, and we will just append it to our initial data. So the base64 encoded data will be on top. We append it with a dot, and we have a nice long string containing our data and our signature. But at least we expect the receiver to also validate this. So let's see how that works. If we just split again on that dot, we have our data and we have the signature. But we also have the public key of our issuer. We have the public key of the government. So we can reverse it, actually decrypt the signature back to the original hash. And since we also have the original data, we can just do the hashing again, and those two hashes need to match up. If those don't match up, then it either means that the data was tampered with and it's not in sync anymore with the signature, or someone is trying to do some naughty stuff and using a completely different private key that was not linked, which was not linked to the public key you usually use for the Belgian government, and that results in a completely different hash that doesn't match up with the data anymore. So this kind of proves that we have a digital signature that proves both the authenticity and the integrity of our ID card. So we have it, right? But if we're gonna be sending out these ID cards in the big world, then maybe we need to at least have a way of adding some additional metadata to it. For example, a way of showing, okay, we use this hashing function to generate our signature so that the receiver can do the same process again. And we just do the same thing as we did with our other parts. We base64 encode it, but this time we prepend it so that we have like a header, payload, and a signature structure. So I think this is starting to look really good. If we go through our checklist again, we already had the first two, right? It's super easily readable by many programming languages, but for many applications. We have a system or a way to know if the card is expired or not. And at least now we're also protected against fake ID cards, right? With the digital signature, we're also protected against data tampering. But obviously, I'm not that smart. This is not something I invented, and everything that I've been saying here is basically JSON Web Tokens. Hopefully you guys have already known about this for a while. Maybe it sparked some interest. Maybe you've been using it. Maybe you looked at it and it's like, oh shit, I don't know what this does, but at least you have a story that you can link to it now. Unfortunately, like, it's also known as JWT, but there's this whole thing going on, like, is GIF pronounced as GIF? Is PNG pronounced as ping? And for some reason, they had to do it with this as well. And you have JWT, and some people pronounce it JWT. No idea why. Don't know where the O comes from, but just so you know. They have a super cool website, a public website, where you can just paste any JSON Web Token you find, and you can see whatever is in there. Super cool. They also have a lot of programming, like libraries for programming languages. Yesterday, I gave this talk at a PHP meetup, so that's why you see 3 PHP packages. But trust me, there are JavaScript packages for this, obviously, as well. Probably a lot more than these 3 that we have in PHP, probably depending on a shit ton of other many sub-packages again, but that's not going to bash on JavaScript, right? All right. But why exactly? Okay. Let's go back to the original story with our traditional authentication and see what authentication looks like with these ID cards. So we still basically have the same first step. We still have to enter our username and password in a form on a website. We send that to the server. The server still does the same things. It looks up the user in the database, but instead of now going to the session storage, initiating a session, returning that session ID, now we can just immediately generate a JSON Web Token, sign it, because we are the issuer, and return that to the user. And on every following request, we send along that JSON Web Token again, and now we can just read the contents, verify the signature, and we don't even need to query our database anymore of have shared session storage. So we basically get faster response times. We have to do a lot less database lookups, and we kind of don't really need sessions anymore. But don't quote me on that. Trust me if I say that it's also awesome for microservices. If you get your JSON Web Token from your authentication server, you can just send it along as an authorization header to any microservice that you're talking to. And those services don't really need to have access to a shared session storage. So you're basically already making your microservices somewhat stateless, which is a good thing. But then again, passing tokens around as authorization headers, that kind of sounds familiar, right? Kind of sounds like OAuth2, where we also have access tokens. You're probably, I assume that you are very familiar with this screen. Like this is the default authorization code grant flow that you go through if you want to, if you do OAuth2. So what happens here is like an integration or a client asks for your permission to access data on your behalf in another system, right? If you go through this entire flow, this authentication code grants, then at the whole end, you get back an access token and a refresh token to start making API calls. That access token is kind of serving as identification as well. You send it along as an authorization header. That server will have to look up whoever is linked to that access token and return you some API results. The refresh token is a second part of the OAuth2 mechanism, where usually an access token is very short-lived, like for a day or for a couple of hours, and you use the refresh token if you want to pick up API communication again. It's like a best practice to do that, but not every API has a concept of refresh tokens. So if those access tokens serve as a way of identification, what makes that so different from JWT actually? It actually isn't that much different, and cool things happen if you use JSON Web Tokens as that access token. So imagine instead of just randomly generating access tokens for API communication, that we generate a JSON Web Token containing all of the relevant data required for OAuth2. So we have the issuer, whoever we got this access token from, team leader in this case. We know the subject to who it was issued to, so the user that completed this flow. we have information about when this access token was issued and when it will expire. We also know what scopes were requested in this flow, so we can easily check, okay, do you have access to this data or don't you? This means that we also don't really need a table to store our access tokens in anymore. I mean, at Team Leader, there's been a couple of times where new developers start experimenting with the API, and they come to me and say, okay, Jens, I'm debugging this issue, I'm trying something out, can you point me to the table where we store our access tokens? And I'm like, do you have like 10 minutes? Let's sit down, let's talk about JSON Web Tokens, because we don't store access tokens. And it's cool to see like this when they start realizing how cool it is. I really love it. Another cool thing is that now, because all of the relevant data is inside your access token, your client can do some additional verification as well. He can check if the scopes he requested are actually assigned to him, or he can also check if it was expired already or not, so that maybe he can use his refresh token to fetch another access token. We don't need, like I said, we don't need any database calls anymore to validate any access tokens. We can just get the ID, the scopes, just from the access token. And the super cool thing is this works really great when you're using a microservice architecture. I mean, you get your access token from your OAuth2 server, your authentication server, and you just pass that along to all of the microservices that you are requesting. The cool thing is, if one of those services also has to query another microservice, he can just pass along your authorization header, and you're authenticated on that server as well. Another cool thing to say here maybe is that if you are using an API gateway, not sure if you're very familiar with the concept of an API gateway, but it's basically somewhat of a like reverse kind of proxy that sits in between all of your microservices and routes all your requests to where they need to go. The cool thing is, because now you have a single entry point, the API gateway can also serve as the first barrier to validating all of those access tokens, because the data is just in there. That's the only part, the only real server that needs the public key of the issuer of your authentication server, and he can already see, okay, is this request headers coming in? Is that valid? Has this token been expired? And he can hold off a lot of bad traffic before it even enters your infrastructure. However cool JSON Web Tokens are, there are also some downsides. But most of them, like some of them, are actually very similar to issues there are with real-world ID cards. Imagine that tomorrow I change my name. That means that my ID card is not representing the real data anymore. I need to go to the government and say, okay, I want to change my name. Please give me another ID card so that at least I can go fetch my new packages that are being sent to me. Same thing goes for JSON Web Tokens. If you put data in there, that data can go stale. So the main thing to note here is embed only what you need. If you're gonna embed additional settings in there, do I have dark mode? Don't I have dark mode? If you start changing your settings, then you need to know that those will not be immediately reflected in that JSON Web Token. So only embed what you want. And as an additional thing, if you keep your lifespan of the JSON Web Token small enough, then you force people to constantly request fresh ones. Like if you limit it to half an hour, in worst case, you're stuck on light mode for another 30 minutes, and then after 30 minutes, you can enjoy dark mode. Then this is like somewhat of an edge case. If your private key gets leaked from your authentication server, then shit really hits the fan. You can basically impersonate everyone as any user on the system. For example, if you by accident commit your private key on GitHub or something, the only thing you can do here is try to identify or see that has happened and just issue a new private key and a public key pair as soon as possible. What will happen then is, because all of the requests are now still all of the ID cards that have been issued will still have the old signature, and you're just all gonna reject them. So all of your users will be logged out, which kind of is a good thing if there was that big of a security leak. Another thing, if in the real world, for example, if my ID card gets stolen, I call the police and say, okay, my ID card is stolen, put it on a blacklist or something. Same thing happens with JSON Web Tokens. If I want to really, if I want to revoke a certain access token that is floating out there, you're gonna want to have, there's not really a system to easily reject those because they're floating around and you're not storing them in your database anymore. But what you can do is you can build a blacklist and see, okay, if a request comes in and that guy is on the blacklist, at least I can reject him. Having only a blacklist is already much better than just storing all of the access tokens. I mean, how many items will be on our blacklist? I can imagine that table on its own will be quite short. If you have as many API users as we have at Team Leader, trust me, that table would be huge. So another thing you can actually do is reduce the time span here as well. Like, let's say if you have tokens that are valid for about 15 minutes, worst case is if you want to ban someone from your system, that user still has access for that lifespan to his data. Is that a bad thing? That's up for you to decide or for the organization to decide. Another somewhat downside of JSON Web Tokens is the more data you embed in your token, the larger it's gonna get. It's just a JSON object that is base64 encoded. So don't start adding like your profile picture in there, also base64 encoded, because it's gonna get huge. And you're sending this along to every request, even within your infrastructure, so that will result in quite some bandwidth if you do. So just keep that in mind. Main thing, only embed what you really need. This is not really a downside, but maybe like a pitfall, because a JSON Web Token looks like it's not readable. It is. It's just base64 encoded. Keep that in mind. You can read whatever is in there. Don't expect data to be secret. That's like a big pitfall that a lot of users have. If you really want to have secrecy, don't use JSON Web Tokens, but just use plain encryption. I mean, we are using asymmetrical cryptography to create our signature. Just do asymmetrical cryptography on your entire data, and then at least it is secret, but that's not what JSON Web Tokens are for. There's also this whole extension on top of JSON Web Tokens called JSON Web Encryption or something, but I haven't really looked into it because I don't really see the need for that. So basically, if you want to store anything on the client, make sure that it doesn't contain any sensitive data, right? Maybe something small to add. I mean, JSON Web Tokens, it's not the holy grail. It doesn't mean that tomorrow you need to go to your CDO, say, I learned about JSON Web Tokens, we don't need an access token database, like a session storage anymore. We can ditch this entirely. JSON Web Tokens have have a very good use case, like what I explained with the whole API communication. That's a super good use case for JSON Web Tokens. You should really use it for that. But don't start replacing all of your sessions with this. It's not meant to replace sessions. And you need to keep in mind that there are downsides attached to JSON Web Tokens as well, and you need to keep those in mind and maybe build in like features or systems to battle those downsides, right? Like holding that blacklist and stuff. So keep that in mind. For most of the use cases, if you're building a small website, plain old sessions will be just fine. It's kind of a bit like blockchain, I guess. Blockchain is good for a couple of things, but just don't put anything on the blockchain. Same goes for JSON Web Tokens. But wait, there's more. Most of the blog posts that you're gonna look up online are indeed gonna go about the use case of using JSON Web Tokens as access tokens in API communication. But there's actually a couple of more use cases, and I think this one is a cool one, where maybe you have like single-use email verification links or password reset links that you want to send to a user. You could use JSON Web Tokens for this as well. Usually, I guess you would just generate a random string of numbers, link it to a user, and then have like a cron job running in the background, removing all of the entries that are expired by now. With JSON Web Tokens, you don't have to do that. You don't even need to have a database table for this anymore. Just embed whatever is relevant for you, maybe like whenever it was issued, whenever it will expire. If you only want the link to be valid for 24 hours, put that in there. Maybe include a version number so that you can identify certain versions and links. And just paste this at the end of a URL, and you have your email verification link or your password reset link. This is actually also a cool use case where you don't really need to distribute public and private keys. You're the only one who is generating these links and receiving these links back. So in JSON Web Tokens, you also have an alternative signature method, just using like a hashed, a salted hash. So just so you know. But that's basically it. Are there any questions?
Working a lot with GWT tokens, but I never understood how reset tokens work. So is it so that the client should remember the reset token, and then when the GWT token expires, sends a new request to the authentication endpoint with the reset token, or?
I think with the reset, or at least what I think with the reset tokens, you mean the refresh tokens? Yes.
That's what I mean.
So usually the access tokens are JSON Web Tokens. They're short-lived, maybe 15 minutes, maybe an hour, and you have the refresh tokens, which you do still have to store in a database, right? So if your access token expires, you need to use your refresh token again, query the authentication server, and fetch a new access token so that you can resume API communication.
Okay.
The main point of that system is that at least you are going back to the Belgian government often enough so that they can check if you can still have access to do all of those things.
But refresh tokens aren't really set in stone by GWT. It's something you create yourself, or?
Refresh tokens are not even remotely part of JSON Web Tokens.
Okay.
It's part of the OAuth2 framework.
Ah, all right.
So those have access tokens and refresh tokens. JSON Web Tokens is basically just a way of securely transmitting information. The both of them just work super together.
Okay, thank you.
So if you're using asymmetric key sets, do you ship your public key with each service that has to validate the signature, or is there something else in play?
If you want those services to verify that token, then yes. But like I said, if you put a gateway, an API gateway in front of all of those services, you can move that responsibility to the API gateway. You just need to make sure that nobody can access those servers like bypassing the API gateway.
Yeah, using trust proxy or whatever.
Is that it? No more questions? All right. I hope I was able to spark your interest into JSON Web Tokens. If you're as big of a fan as I am of JSON Web Tokens and you want to work with them in production, blah blah blah, we have we're looking for colleagues. Back to you, Nick.
All right, thank you, Jens. Thanks again, Jens. And this concludes our very first GhentJS meetup. So thanks everyone for attending. There's still quite some beer left if you want to grab a drink and talk, network, all that stuff. Finally, there's Marijn? Nee. Okay. No, there's still room for the next meetup. We're still looking for speakers. So if you're interested in being like Jens, being a star of the night, come to us. So Huus, me, or Klaas, who is there, or reach out on Twitter, GhentJS.